Here's a synthesis practice problem you should try. So I would pause the video and see if you can use what you learned to start with cyclopentanone and add this ethyl group to the ring. All right, so our strategy for this is to remember that alcohols and carbonyl compounds are only one step apart. So remember that if you have an OH, you can oxidize that into a carbonyl, and you can reduce a carbonyl back to an alcohol. So even though this alcohol in the starting material isn't yet a carbonyl, we can think of this kind of being an alpha and a beta carbon. And what we're trying to do is end up with an ethyl group at the beta position. So the steps we want to take is basically going to be to get the alpha beta unsaturation and then add the ethyl group through cuprate chemistry. One mistake people will often make is to forget about the fact that you need to have the carbonyl to do any of that. So our very first thing we want to do here is to oxidize. You can use PCC or chromic acid. It doesn't really matter here. Let's just use PCC and oxidize this to the ketone. Now that we have that, we can get an alpha bromine. We'll use Br2 and acetic acid. And that reaction requires the ketone. It will not work if you start at the alcohol. Next, we can do the elimination. So add pyridine and heat to eliminate the alpha bromide. That gives us the alpha beta unsaturated ketone. Now, since we have an alpha beta unsaturated carbonyl compound, we can add the ethyl group through cuprate chemistry. So I'm going to add ethyl cuprate. And we need 2 ethyl groups on the copper, followed by a water workup. That will give me the beta ethyl group. We're almost done. We just want the alcohol as the product, and you can get from the ketone to the alcohol through a reduction. You could use LAH or sodium borohydride. I'll use sodium borohydride. And now we have the product.